Okay, in this clip, I'll show you how can we evaluate the different model or the different um, learning algorithms. So I'd like to, but in in your stage at this point of our course, you just studied decision tree learning, right? So I would use another one that is like not so difficult. It I think it's very easy one also, but I think it's quite good for classification problems. So we continue from the last video clips that we used. I hope that you can still remember that. We used the data from here, the breast cancer, but we used just only, actually, there are 10 attributes, but we will skip this one. Oh, sorry. We will skip this one, attribute number 6, that has the missing values. In last video clips, we start with the simple one, that is the using the train test split. But in this clip, we will use the different one. We will use the uh, k-fold cross validation. Uh, so I'd like to start now. To use the k-fold cross validation, we will start with this one. From sklearn model selection, we have to import the cross validation score, and we will use the stratified k-fold. The stratified k-fold is the one that divide the data into fold, but it try to keep the distribution of the data. The portion of each data will be kept in the fold. Okay. Next, once you can import this one now, we will create the cross-validation data set. Here, we will start with the stratified k-fold. Guys, I'd like to run it first to make my collab know the stratified k-fold, so it can give me a hint. So I'll start with the stratified k-fold, this one, and we use the n split to be 10, and we set shuffle to be true, and we set the random state to be like 31, for example. Actually, you can omit these parameters. You can set start like this first, and then we will try to investigate each parameter later. Okay, so next, we will create the classifier that I think that you still remember, right? We have the decision tree classifier, and we we have to build the x and y from the last uh, example, the last video clip. That here we have a x, that is the training example, training vector, and y is the test vector, the output. Okay, so x is here. You can use the source code from the previous video clips that read the breast cancer, skip the sixth attributes here, and then choose x and y, store it here. Y is the last attribute, that is the class. So x will be index number 1. Index number 0 is the index, so we'll skip that one. It will be 1, 2, 3, 4, 5, 7, 8, and 9. And then this is the distribution of your training data. Oh, sorry, the whole data for the class 2 and class 4. Okay. Uh, okay. So for the class 2, it is benign, and class 4 is malignant. So once we have X, or once we already have X, we can create the decision tree classifier, and then we can keep the score to be, guys, look at this, cross validation score of classifier and X and Y. And the cross validation, normally it can accept the number of n, but this time it can accept the cross validation generated from the stratified k-fold. So you can set CV is CV. And finally, once you finish this one, you can show the score. Here, this one is the score that you can get from each fold. I hope that you can still remember that. If we have the first fold to be the test, we will use the remaining to be the training data. So guys, this one is the score from using the first fold to be the test one. This one use the second fold to be the test, and the remaining will be training set. And this one, and so on. This one is the third fold, the fourth one, and this one is the last fold. So this one is the score of your data. This is a list, so you can use a score like if you want to get the average of the score, you can use score.means. So this is the average accuracy from all folds. Or if you want to get the standard deviation, you can use STD to get the standard deviation. Okay, so this one is the first model from the cross-validation one. So I hope that you can see we have means and we have standard deviation. So it can be compared to other classifier. So this time I'll use the other classifier. Look at this. I'll use the KNearest neighbor. So from sklearn.neighbors, I'll import the KNearest neighbor classifier. The idea of KNearest neighbor classifier is quite simple. It is called the lazy one. I'll talk about this later, no worry. But the idea is like you have the data set and you provide the test data. It will compare and measure the distance from the test data to all other training data, and it will find k closest data in the training sets, and it will the result will be voted from all k's closest data. So this one is the k nearest neighbor one. To use it, it's quite simple. I will change everything to be like classifier 1 and score 1 here. So this one will be the classifier number 1, and I'll copy and use the classifier number 2. Look at this. This one is score 2, and this is the classifier number 2, and it should be the k nearest neighbor classifier here. So k neighbor, you import the k neighbor, right? Classifier, and the neighbor. We always use the number of neighbors to be the odd one, because if in the case of even numbers, maybe it's like some situation like the two of them are positives and the other two are negative, so we cannot get the result. So normally we use the or the odd number for the n neighbors. So guys, after you run it, now you have score 1 and score 2. right? Okay, so I would like to show you the score 1 here. This is the result. This is the score 1. This is score 2. This is the nearest neighbor. Score 1 is from the tree and score 2 is from the nearest neighbor. So you can see that we have the score 1 and score 2, right? So the best way to compare it is you have to compare it using like the average and the standard deviation. But you can plot it also. The box plot can help you to evaluate the result from two different algorithms. So guys, look at this. I'll show you how can we use the box plot from the pandas one. At first, you have to store all of them, all data in score from scores 1 and scores 2 into the data frames. So I will show you the score data frames. It will be the pandas data frame. Okay, so I would like to add the columns to be a list of, the first one is tree, the second one is KNN. Okay, so this one I provided like the name of the columns also. So guys, once you finish creating these data frames, you can see that we have an empty data frame that there are two columns, that is tree and KNN. So for the score df, I will store the tree score of the tree from score 1 and I will store the KNN from score 2. So this one, score 1 and score 2, and show the score df. So this one is the score of each fold. So I hope that you can see from index number 0, this is the fold, the score of fold 1 compared with 3 and KNN, fold 2 that indexed by 1, 3 and KNN, and you can see that most of them, for actually there's just only one fold that the tree is higher, but for the other folds, oh, this one is same, and this one is same, and this one is KNN is higher. So now it's like it's like we have tenfold, right? So the best way is you can compare it using the average but and standard deviation, but to make it like clear, so you can show some graph, that is the box plot of the pandas. So I'll show you the score df using the box plot, this one, the box plot. So um, you can show the columns of 3 and KNN. But it's actually if there are just only 2 of them, so you can omit the parameters, and you see that from the tree is a little bit lower here. Can you see this one is a little bit lower, and KNN here is higher, and you can see this one is like a percentile, sorry, the quartile 1 and quartile 3 of each data. This is the box plot. So so you can see here we have like 3 and KNN. Okay, so so you can run it many times. I didn't provide the random state here. So when you run it, you will see the result here. So uh, it's like it's different from the previous version, right? So the best way is you have to fix the random state if you want. The way that you can fix the random state is you have to set shuffle to be true, and you set the random state here to be like some number like 31, for example. So if you fix it like this, you can run it many times, and of course, it will show the same one. Oh, it's not the 3. It must be true. I'm sorry. Okay, so I run after, and you can see that here. This is a result from this random state, but uh, we make it like tenfold, so it is like can be more robust than using the train and test split. Okay, so because you can see that in some data from the previous examples, you can see that in some fold the tree is a little bit higher than k and n, but this one is like okay, it is this one is the median and min and max. Okay, and q1 and q3. So this is the box plot of your data. Okay, and the last thing that I will show you is if you want to measure the significance level of your result, you have to, like, you can do it like this, because now you have 10 pairs. You have 10 pairs of the data here. 10 pairs of the data. So the best way to find the significant level of the results from these two models is you have to compare it using the one-tailed pair t-test. The values can be obtained from the Excel also, or you can use the stat from SciPy in Python to measure the p-values of them. So guys, I will show you the SciPy, and if import the stats one, and you can use stat and t-test. This one. This is the, sorry, I would like to run it first, and you can see that it will have the stat dot t-test. This one. This one is the t-test. This one is the t-test of the two datas. Okay, so you can use score 1 and score 2 to be inputs, and now you can run it, and this one is the results. That this is the t values of the result, the different, and this is the p values. P values is the values that you can use to report in the paper that this one is the significance level. If the p values, guys, if the p values is less than the values that you want, the level that you want. For example, if you set the level as 0, point, look at this. If you set the level p to be, or actually it should be alpha to be like 0.01. So if your p values is less than this alpha, so you can report that the significant level is 0.01. This is like very, very good. So you can be confident that if you run it many times, it will be the KNN will give the higher result. Okay, so this one is the values that you can get from the statistic methods that you compare to values from different models, and you have 10 values, so you can run one-tailed pair t-test from the result that you get from your model. So I will keep this one and show you the actual data in Excel also. So I will write score df to an Excel file, and then I'll use 3 and 3 and KNN dot XLSX. So once you create this Excel file, you will have the 3 KNN.XLSX and you download it. Okay, once you finish downloading this file, now you can open Excel and please wait for a moment. Okay, I've just downloaded this file and I'll show you in my screen. Show you on my screen. So this one is the I have to okay guys, no, sorry, not this one. This one is the result. So this is the score or the accuracy from two models that we ran in our system. So here you can use Excel, that is t-test from both series, and it must be one tail and paired t-test, because we compare it like fold by fold. So this is the result. This is the result of from the Excel file, and here you can see that this one is the significant level, but the p-values from Excel is a half of the p-values that you got from Python, because from Python this p-values is two-tail. It's two-tail. So I think if you like if you worry about these words like the statistics, paired t-test, one tail or two tails, I think um, the topics is like the basic of this course. So you should know about these terms before, but if you forget about that, no worry. You can think about the like the distribution, or you can search for the distribution curve, the area under the curve of the distribution. In If you want to compare that is equal or not equal, it will have both sides of the area under the curve. But if you want to compare it like greater than or less than, you can compare it just only one side. So if you have only one side, you can the values, the p-values that you can use is half of the p-values that return from this stats.t-test. So if you times by 2, it will be same. Look at this. Or here, can you see? This one is same. Or if you divide, actually you should divide its p-values by 2. And then you use that one to be the significance level. So this is the p-values and the significance level. I'll show you something. If we run it using like other random state, like for example, if I run it, use 1 to be the random state, look at this result. Can you see now the box plot of KNN is a little bit lower, so it has some overlap zone. Look at this. This is the overlap zone. So maybe, can you see? This one is the p-values. The p-values of this set is a little bit higher. So if you check the alpha, look at this. the last one, I hope that you can still remember. Our alpha, if we set at 0.01, so this p values divided by 2 is still higher than this alpha, right? The p values divided by 2 will be 0.014, right? Here, the p values divided by 2, this one. This one is like 0.0140007. So it's still higher than alpha, because if you set alpha to be 0.01, this one is higher. So you don't have the significant level at that level. So you can increase this one to be like 0.05. So if you set alpha to be 0.05, so you can have the significance level at this state. Okay, so 0.05. So in this random state, you will have the significant level at 0.05 between two of them. So you can say that the accuracy from the KNN is higher than the tree with the significance level at 0.05. Okay, so this is about how the way that we can use to compare to learning algorithm. Normally, if we report in the paper, in the research paper, you can use the standard deviation and the means of the result from the algorithm, also like use means and plus minus standard deviation. So that is the one that like many people used that style to report the result, and the significant level is also same. So you can see that if we generate a random state or different random states, maybe the result, the significant level maybe is different. So we have another things to do about this, like you have to do it 10 times, about like do tenfold 10 times to make sure that to make sure about the significance level and which one is better. This is the like the upper level of confidence. So but normally we use k-fold or tenfold cross validation is fine. And the default option in sklearn, you can see the number of fold is 5. So fivefold, tenfold, fivefold to tenfold, I think it's fine. Okay, so I hope that you can get the idea, and how I hope that you can write the code to evaluate to learning algorithms.